In this video, we show that Gmail's authentication logic contains a flaw which allows an active adversary to gain access to a user's email by truncating a TLS connection. The attack works under the standard assumption that the adversary controls the network and may access a computer shared with the user. But, we stress, the attack does not rely on tampering with the user's computer. This setting is typical of shared computers in public libraries and workplaces, for example. In essence, our attack works as follows. A user visits Google from a public computing terminal and authenticates a session. Once the user has finished searching, she also visits Gmail, and a session is seamlessly authenticated by Google's single sign-on service. After she's finished reading her mail, the user returns to Google and eventually makes a logout request. The server responds by guiding the user's browser for a series of further requests which are intended to terminate each active session. In particular, this procedure should ensure that the session with Gmail is terminated. However, we have observed that it is possible for an adversary to truncate a TLS connection, thereby dropping the logout requests which should be sent to Gmail without the user's knowledge. More precisely, it is possible to prevent the Gmail session from terminating and ensure that the user is still given feedback that suggests her logout request has succeeded. The attacker can then use the public computing terminal to access the user's Gmail account. For the purpose of this demo, the public computing terminal is modeled as a virtual machine running from an ISO image, and the network is modeled as the host, which the adversary is assumed to control. In advance of the attack, we assume the adversary has analyzed the network traffic to determine which packets should be rejected. In practice, the attacker may use various techniques to identify and reject packets, and we have simply configured IP tables to reject packets of length 1165 to 1195, as can be observed from our IP table rules. Let us now switch to the virtual machine and observe the attack in action. The user visits Google and authenticates herself to the system. Once the user has finished searching, she visits Gmail and is seamlessly authenticated by Google's single sign-on service. Once she's finished reading her mail, she returns to Google Search. And she may also like to close her Gmail tab. And once she's finished searching, she'll eventually make a logout request. The success of her logout request is indicated by the sign-in option in the top right-hand corner of the page, rather than her email address and photograph. We can now modify our IP table rules. In particular, we can drop the rule that rejects packages, return to the host machine, and access Gmail. And as you can see, the adversary has full access to the user's account, despite the fact the user logged out. And from here, the adversary can read the user's email and basically has full access to her Gmail account. However, if we visit Google Search, we will immediately see that the user is logged out here. Similarly, if we go to Drive, the user has no session there either. And if we go to google.it, again, no session. In fact, if we go to Gmail, the user has no session there. But if we go back to search again, we can access the user's email account still. And that concludes our attack. Thank you for watching.